here I can see anyone, but still. So my talk is structured as a rant. So I'm going to rant for like 35 minutes, and then we're going to have time for discussions. So if you have any questions that arise, please keep them till after the talk. So as you may have heard, I work at Zalora. I work at a team that does site reliability engineering, right? So we do basically a platform. We write platform software. I'm also an undergraduate student, and we're also hiring. So if you're excited about what you will hear, please let me know. And if you want to work with us, obviously. OK, so I'm going to talk about DevOps, right? This is a very overloaded term. It has been very popular for the last like 3-4 years, whatever, right? But basically, this you can't find a single definition for it because there are so many, and the only common word that you can use is just that DevOps is the glue between something, right? And basically, it has been very popular recently to come up with different ways you can glue different things to other things, right? And like software-defined networking, you just add APIs to like network devices, and you get basically glue them together, whatever. So DevOps is the same thing, right? It spans a bunch of topics like configuration management, running systems, monitoring them, immutable infrastructure, and all of those buzzwords you may have heard. They're all about DevOps, right? But I'm gonna talk here about the core product of our team that is codenamed Microgram, which is like Instagram for microservices. And the main idea is that our users, which are developers in our company, they deploy a bunch of applications, right? And they need them to have them deployed in different configurations, and they need to express some properties about those applications, like how to monitor them. Basically, we provide them with an API to do that, and with a runtime that makes sure the definitions actually happen, right? And it's one of the main goals of this runtime, so errors show up sooner rather than later, right? Because, well, if you provision an application to 100 nodes, and you do this by mistake, or you mess up the configuration, you pay for 100 compute units, right? So one of the things that come out of the idea of the API and is quite ubiquitous in DevOps is that every single company that provides DevOps tooling or any operation stuff, or historically in systems administrations, right, are DSLs. Right? DSLs are everywhere, and basically they allow you to express systems and code. So to start now, I'm going to go over some like basic DSLs in the sysadmin world or the DevOps world that you may or may have not been familiar with. So right, that's the most popular file ever. Just describes list of users, right, and their home directories, and it's also it also used to contain passwords, but it no longer does, right? And this is basically a CSV file with colons as separators, right? It doesn't do anything smart. It just describes data, right? This is a configuration file to a packet filter, which is like a product of the OpenBSD. And a packet filter is essentially a firewall, which is now so popular that it's shipped with every iPhone or whether every MacBook. And the idea of its configuration file is that it basically lists a set of rules, and the thing that evaluates those rules picks the last matching rule, and which wins. However, this is not enough for some kinds of expressivity, so it has some kinds of macros, which you can see there with $signs, right? It has some string descriptions to some numeric concepts, and so on. It also has some special keywords that alter its control flow. Like it's not listed on the example, but if you say pass quick out, it means that the first matching rule wins. So there is a way to do smart things in a declarative language, right? The next thing is SendMail, which used to be the most popular mailing transfer agent ever, right? Which was written by Eric Oldman, and its configuration, and it's written in M4, which is like a macro language. And if you've never written in M4, I'm so happy for you right now, because, well, I've once seen a real story of a CDN company that had its configuration tool written in M4, and the purpose of doing that was to prevent people from actually touching that configuration. Yeah, so this is a true story, right? And M4, it's also used in all sorts of weird applications like audit tools, right? This is basically what you have to go through if you want to build a C program, right? And yeah, this is basically, right now I'm trying to show that other people have different pains, right? Anyway, so the most hipster language to specify things right now is JSON, right? So it's basically a term that has some basic data structures like lists, dictionaries, strings, and numbers, right? And everybody has seen JSON because it's like everywhere. You can even go to the tube and see like ads written in JSON, right? Because it's cool and everybody understands it and thinks this is something related to programming, right? And you may be right because it's actually possible to do programming in JSON, right? So this is a configuration, a snippet of configuration from a tool called Amazon CloudFormation, which allows you to express real infrastructure, but apparently it was not enough to specify configuration using keys and values. So the guys at Amazon were very smart and tried to encode computations in JSON, right? But obviously you have to encode them as strings, and right now, every sysadmin who uses CloudFormation is basically doomed to write 2 kilometers of JSON to specify a system, right? So another example of basically this is the language that's totally isomorphic to JSON, except with one exception that its specification is probably 100 times longer than the original JSON specification. And this is an example that you could have seen on a previous talk about Ludwig, right? That this is a snippet taken out of Ansible. Then this language is not expressive enough, so you have to use string template libraries to expand while you evaluate this file, because it's apparently not declared enough, right? And you can also do programming with YAML as well if you encode more things and somehow document them so people can actually make code here work, right? Another thing is Puppet, which is a very interesting language. It's a domain-specific language that has the main primitive that's called a resource. And the evaluator of the Puppet language, it makes sure that those resources, their predicates are met. And if they're not, they do some action to make sure that predicate is met, right? However, Puppet was interestingly designed. So it's not exactly declarative because it doesn't, its evaluation sometimes depends on the source code order, and it doesn't make it usable in a lot of scenarios, but it's very good to describe resources. And it also has some cool features like pattern matching for strings, which is nice, right? And there's also Chef, which is the tool that does pretty much the same as Puppet, except its DSL is embedded in Ruby, right? But to do smart things, you have to define things like Ruby block and do side effects. So like in this language, it's really hard to do side effects, and in Chef, it's a little bit simpler. But it's still hard to reason about this code because, well, why would you want to have a Ruby block that slips for 30 seconds, right? OK, so what's the problem, right? So DSLs are like drugs for sysadmins, right? When a company that invents a DSL, they give it to you and force you to use it, right? And it's really hard to go off this drug because anytime you root into so many features that this DSL provides you, but anytime you want to walk out of the box, you have to invent something, or it will usually take you a long time to invent. So you just go to this company that gave you this DSL and say, hey, I want this feature, and they charge you like millions of dollars to implement it and roll it out, and you use it. So the way how some people try to work around that is to use the ultimate systems integration tool, right? And this is a conference about Haskell, right? So obviously, I'm going to talk about Bash, right? So apparently, Bash is the ultimate system integration tool for reasons that is pretty much ubiquitous. You can even have bash in Windows, but the code that's written for bash may not run on other shell implementations, right? It's really hard to scale because its execution model is really tied to Unix, but there are so many scenarios that people actually try to use bash in. It's really scary. So, and another interesting thing about bash is that, well, those languages have some kinds of types or notions of values being things actually have different syntax for different types. In bash, everything you say is a string. And operations in bash, they depend on the context of the operation. They do type coercions and do some kind of computations, right? So it's really hard to write in a language. But it's actually possible that people actually do complex systems in bash, right? So we basically had to do this thing too, right? And we had to come up with a way to scale bash, right? And given that this is a conference about Haskell, I'm going to talk about Nix, right? This is another language that we use to scale bash. And if you're not familiar with Nix, it's three things in one. First of all, it's a package manager. Next, it's a distribution of Linux based on that package manager. And third, it's an expression language. So the expression language is actually pretty cool, and it turned out to be a huge time sink of fun. But it's also based in lambda calculus, so it's really familiar to people with functional programming background, but it's really bad to use for people who do not have this background, right? But the core mojo of Nix is string interpolation. So consider your regular bash script. So this script does some web service calls. And it uses a bunch of dependencies like bash, curl, awk, JQ, OpenSSL, core utils, and so on, right? And Nix, its expression language, allows you to assign values to bindings, right, and embed that into source code. So when Nix compiles the string, it replaces those variables with paths to executables, right? So Nix, and the means to do that is a single side effect that's hidden inside Nix, which is called the derivation. There's a single concept that's used to build the whole package management framework, and it's pretty cool. And however, the language is dynamically typed, and the repository of Nix packages, which is like a list of those like cute strings that used to build packages, right? It's hard to maintain, so the developers of Nix have to come up with a lightweight schema validation embedded DSL to do typing-like things, which is also good, right? But Nix is also like a very fun language. This is a really obscure snippet of code, and you can see that you have like lets and like function applications, and like there's a embedded data structure that's called an attribute set, which is like a dictionary, and you can merge them and stuff like that. But it also shows that there's lexical scoping in the language, and it makes it really interesting to use. So the main experience with Nix is that with any dynamic language, you can change anything, and nothing's going to stop you, right? So like keep on or enter. I'm a sign, not a cop. This is our main experience of using a dynamic language for building a more complex system. However, we actually succeeded to do that, right? So we built the application that we described. Effectively, that's bash on steroids. We use Nix and a bunch of cool properties about it to compile it to bash. Right? But one of the problems was we used a package manager to build a system. Well, while we actually reuse some of the cool concepts that this package manager gives you, it's like really using a hammer for some things you can't use a hammer for, right? So we tried to work around some of the deficiencies, like trying to embed more EDSLs in this dynamic language. We tried to make it more Lispy, which made things worse. The other thing, we tried to experiment with trying to make API checks because, well, it's hard to make private APIs in a dynamic language because there's nothing private in a dynamic language. Just go somewhere and steal a value, or like set another value, right? We tried to add side effects to this language, so we actually added a monadic DSL to Nix that allowed us to do things like decrypting files or other like limited side effects, but it was really sad to look at. And the whole system overall was really somewhat boring to work on. Okay, so, and while we were looking at Nix, we were thinking, hey, so we can use this concept from Haskell in our code. Or, look, those guys invented this concept, and we could have used it in our language, in our code. But eventually, we decided, well, why not just use, the language that has all the concepts from the box, out of the box, right? So we kind of had some prior experience to use Haskell for that, and we actually used like this tool Opcast. This is currently open source. It's being used in microgram, but like as a tool that's being used aside. It allows you to specify infrastructure in Nix and then like evaluate it. It's basically, you started as a clone of NixOps if you heard about that, and then we kind of got excited. So we have a bunch of other tools like Replicator from MySQL, like sproxy, but it's somewhat abandoned. There's a web GUI for sproxy who's written by a person in this room, and a bunch of other cool things, right? It also allowed us to look differently at common Unix tools, like cron, right? And if you think about cron like it was designed, it's basically a tool that you can use when you log in on some box, and there's one huge cron that lets you run periodic jobs on the box, right? And we implemented a single user cron in actually 7 lines of Haskell if you don't count module imports that we actually use in production. And a bunch of interesting things on our GitHub. So the thing is, when you think about our experiences integrating Haskell with the rest of the stuff, we spend a lot of time marshalling things to other strings, to one types of strings to other types, right? However, the HCI shell is a lot better shell to use because at least like these the values that you type in, they have different syntax for different types, which is already good, right? And one of the other experiences with Haskell is that whenever you compile something, you have to wait, which doesn't happen when you use dynamic languages or dynamic systems or whatever, any other tools that are out there on the market. So I'm going to step back a little and talk about some other experiences with Haskell. And one of the hot topics here is deployment because of the stack came out, and we hope it really solves most of our problems, right? So Nix packages is the package collection that comes with the Nix package manager. It has its own Haskell infrastructure that kind of reuses Cabal and maps it into whatever Nix gives you. And it pioneered curated dependency sets before it was cool, because essentially if you download a Nix expression collection, you see a bunch of different libraries with that are bound to different versions that are known to work together, to compile together because they were tested on the same CI, which is pretty cool. But however, this approach has a lot of deficiencies. Like it has a lot of packages that are built with Nix. They have a lot of dependencies because, well, the language is too expressive. It's so easy to add more dependencies that you can do this like a click, right? And it's kind of bad with distributed builds because there's a bug in GHC, which is the ticket number 4012, that basically says that if you compile the program twice, the same program twice, it may give you different, or the same package twice, it may give you different package hashes every time you compile, which means because, well, GHC is in some places is non-deterministic, and I think it happened like that because people were trying to make GHC parallel, and it kind of had some side effects like non-deterministic builds, and it really hurts people who try to package Haskell, right? But anyway, if you look past beyond those limitations, you can come up with an idea to use Nix really effectively. And if you like to hack on GHC, please take a look at this ticket because, well, it needs really needs attention, and it's actually started getting some recently. But also how people approach Haskell, they just copy source files on the target box they're going to run it on and just build it there, which is like the most popular way to deploy interpreted code, right? But not compiled. But this is what people usually do with Haskell, right? Or they can build it on one box and then copy it on some boxes that have the same operating systems and the same dynamic libraries. And there's Docker, which is quite fun, but it makes the distribution easily bloated if you don't use it right. And yeah, and there's higher hope for Stack. So the cool part, it seems that like if you ever use Golang, and if you didn't, I'm really happy for you. It lets you, the good thing about it is it lets you build static binaries and even cross-compile them. You can actually build a Linux binary on your Mac and then just copy it and it will just run. And this is because Linus Torvalds promised everybody that the syscall application binary interface is never going to break, right? So Golang really exploits this property, and it lets you cross-compile binaries, which you could partially do with GHC if you compile with something different than the GNU C library. And you also may know that almost every library uses integer GMP implementation, which makes it dynamically link to GMP by default. And you can see Stack, they have to provide two different types of binaries for two different GMP versions. This is kind of weird. And well, this is not weird. This is just how you deploy binaries on Linux, and this is bad. And another cool thing that I thought about really like 2 days ago, or 3. So if you think about Joyent, this is the company that provides SmartOS. And SmartOS is a distribution that's based on open source Solaris, which is currently called Illumos. And they have built a big amount of system software using Node.js. And their Smart Data Center solution and the Manta, which is like S3 plus computations, is built on Node. And there's GHC.js that lets you compile Haskell to JavaScript, right? So if you think about it and you compile Haskell to JavaScript, it becomes really easier to deploy it. So it's possible to seriously consider use GHC.js for server-side applications that are non-performance critical, because it's just simpler to deploy it, right? And there are actually success stories of doing things like that. Like if you think of Lighttable, which is a Clojure IDE / text editor, it's written in ClojureScript and is ran inside Node WebKit, and that's OK. And it really works. So the grand idea, if you want to use Haskell for something like for some big product, you just have to push dumb problems around, right, and just focus on some interesting stuff, right? So it's hard to deploy Haskell, right? Just don't deploy it. Just figure out a way that how you can circumvent the whole process and just do something else, right? If it's hard to write CLI tools and it's boring, just don't write them. Just use, whatever the rest of the Haskell ecosystem gives you, right? And apparently Haskell is ideal for writing glue between systems because effectively glue is mappings between domains, right? And if you add types to those mappings, I mean, there's a really big chunk of work this Haskell thing helps you solve or avoid, right? So there are a bunch of cool things like using parser combinators and wrapping existing interface with types, which this is basically a list of things we're daily doing to use Haskell, right? And so the first thing we had to do is to slowly migrate from Nix, right? And we took all of those schema annotations and map them to Haskell types, and basically we generate strings. There's Haskell code that lets us slowly migrate from the existing code sets and move it to Haskell. And one of the things we use Nix as a query language from Haskell, right? And to avoid some syntax errors and some semantic errors, we encode Nix as a language based on lambda calculus as higher order abstract syntax. And there's a cool thing that's called rebindable syntax, which lets you rebind if then else to call your function. But you can rebind let, and if you could rebind let, you could actually encode pretty much a big number of languages. That would be pretty cool, but it's kind of hard to make because, well, let is kind of special anyway. So there's a lot of integration with third-party APIs, and we're using Servant Client a lot, and props you guys for doing Servant. This is really great. And there are not enough implementations for things like Java developers or .NET developers take for granted, like implementing web service clients. Like there was this thing called WSDL, which is basically an XML description of a web service. And if you feed it some magic Java thing, it generates like 100,000 lines of Java code, and you can just use it. And the current hipster thing is called Swagger that Microsoft uses to encode, for example, Windows Azure APIs. And there are not enough implementations for things like that in Haskell. And like Amazonka is a really great library, and it's actually a tailor-made code generator, but it generates Haskell code from some JSON specs that Amazon provides. Right? And there's a cool feature in F# that is really liking here that allows you to basically provide types from external sources. But I mean, code generation from strings is also cool, but this is like feels like a natural feature. Of course, like doing a lot of DevOps is isolating real effects from fake effects, so you don't accidentally pay $100 for accidentally provisioned infrastructure during testing or things like that. So there are a bunch of libraries to do that. And actually, the Free More and More Extensible Effects paper was so cool on the latest ACFP. It led people who had a hard time understanding mono transformers to actually understand them, and I really had a hard time understanding that. So it's really a great paper that opens eyes on many things and actually enables use of all those things. Yeah. Okay, so integrating with Bash, there's a really popular thing that's going on right now that's called Turtle, and it's used to write scripts in Haskell that kind of look like Bash, but aren't. And we can currently afford that because if you don't want to deploy Haskell anywhere, we don't want to copy binaries, we can just generate Bash code and send it over SSH to execute. So we can just write a tiny compiler for Bash, do our own transformations without even without even having to parse Bash, just using the Haskell syntax. And this is the DSL we have right now with some sugar, and it looks really stupid, but it gets you really, really far. And apparently Unix is a minefield for experimenting with parser combinators, right? Because a lot of performance analysis work is correlating some values to other values, and a lot of performance analysis happens on demand when something actually starts to crash or starts to work slowly, and you have to go in and figure out what you want to measure if you haven't measured that before, and then correlate those values. And apparently this is like a huge playground for using parsec or itoparsec. And if you want to see how it's used, for example, for us, there are 2 repos when you can check it out. So the best case that I can describe here is using so whenever you try to analyze some or transform some configuration files, and you use like huge pipelines of awk, pipe to set, pipe to Perl, and you basically have to type check those things in your head, and as things are actually strings and not any typed values, it's really hard if you come to edit the script the next day. So eventually what you do is you rewrite it in some better language, and guess what it is, right? So there are other notable Haskell tools or like frameworks that I wanted to mention, like Propeller. We don't really use it. We don't use Shake and Bake, but they are really great DSLs for builds and for property insurance on remote systems. And there's a good idea that we wanted to try but haven't yet, is to use literal Haskell for doing scripting, because, well, it's a lot better than comments, and it gives you self-describing code that explains to other teammates what have been done, right? And I stole this idea from there's a blog post that uses org mode in Emacs for doing literal DevOps, and this is a great tool for communicating with your teammates, because a lot of work in site reliability engineering is explaining what you've done to other people so they take note of it. And you have to do this until your system is fully declarative, which is never going to happen, right? because your job is to define declarativeness as you go, and it's never declarative enough, unfortunately. Right, so just if you want to do this, if you want to use Haskell for DevOps, just take a deep breath and say, I got this, because it's really easy. So that's basically the takeaways of what I was trying to say. But one key thing is that if you bring some cool tech on the table to your other teammates and you don't have any added value, you're definitely going to fail. Because there's no happy rewrite that happens just because you want to add types. There has to be an added value in like features or whatever, so you can actually sell it. So don't make this mistake, right? And so there are infinitely many DSLs to do cool things, but there are infinitely many glue that sticks bad. So like Haskell is the best glue here. And don't use bash, please. Thank you. And I'm ready to take your questions. Yes?
So you discussed earlier in the talk that a lot, and you said we can then out.
Well, the thing is, as we go, we already know those languages. And if we would quasi-quote them, it wouldn't be a problem. But we don't quasi-quote because it's easier to use one syntax. Yeah, so that's what we do right now.
So you sort of represent them all in Haskell.
The first reason why I did that is that, so we were using the mixed language as a query language, and I had a data query A that had two constructors, a key path, which is like a next thing, and a string expression. And I miscounted the number of parentheses in this string expression. So I just represented it in HOS, and it just was like a 5-minute hack that like gave me a lot of features. So the main idea here is like doing quasi-quotes and embedding parsers takes time, and there's like the less time you spend, the better. Yeah, I used to do that, but like this F# thing, it gives you this magic feeling that it takes care of all of these things, and it's just nice. Yeah, this is the only reason why I mentioned it. Yeah. Yep. No, and I mean, if even Linux guys don't have this library, right? Linux specification of files/proc is like changed every day, and like it's incompatible between Linux releases. So it's like if you know add to parsec magic, you know, it's like this XKCD comic that send back, I know, regular expressions, right? And you hack into proc. This is the same thing but better, right? Yeah.